In this video, we're going to look at how to find all the factors of a given number. So let's recall that a factor of a given number is a number that can divide into the given number without a remainder. So for example, let's say we have the number 8. Let's just start with a nice easy number. So what's a number that I could divide into 8 and not have a remainder? Okay, so if I take 8 divided by 2, I get 4. So therefore, 2 is a factor of 8. Also, 4 would be a factor of 8 because if I divide 4 into 8, I get 2. Alright, so when you find a number that goes into another number without a remainder, whatever that answer is would also be a factor. So you kind of get 2 for the price of 1. Alright? Okay, now, when something can go into another number, we say that it can be divided by that number, and we talk about divisibility. Alright, so 8 is divisible by 2. Let me write that out, just vocabulary. We would say 8 is divisible by 2, or we would say 2 is a factor of 8. Okay, so over here I have some tests for divisibility. So the big thing is, what if I have this big huge number and I want to find all the factors of that number? How do I even start? Let's not start with a number that's too big, but a number that's a little bit more daunting, like 120. I mean, 8, I could list the factors of 8. As a matter of fact, let's just go ahead and do that. If I want to list all the factors of 8, you're always going to start with 1, all right? Because 1 goes into every single number. Alright, factors of 8. So 1 goes into 8. Now remember what I told you a second ago is every time you find a factor, you get another factor, because 1 times something is 8. 1 times what is 8? 1 times 8 is 8. So you get these two factors, alright? 1 times 8. So then go to the next number, which is 2. Does 2 go into 8? Yes, it does. Alright, so 2 times 4 is 8. Now, I want you to notice that these pairs of numbers are getting closer. 1 and 8 and 2 and 4. If I write it out like this, 1, 8, 2, 4. 1 times 8 is 8, and 2 times 4 is 8. They're always going to pair up like that if you write the factors from least to greatest. They're always going to pair up like this, the ones that multiply together to give 8. So if there was going to be another factor, it would have to live inside there. It would have to be 3, and 3 doesn't go into 8, so we have them all. The factors of 8 are 1, 2, 8, and 4. Okay, so that's kind of the process we're going to use. Now, let's use that same process for 120, and we're going to have to check some more numbers this time than just the ones we had to check with 8. So here's some shortcuts for divisibility, or some tests for divisibility. To see if 2 goes into a number, we need to see if the number is even. So 120, that is an even number, right? It ends with a 0. If it's even, it ends with a 0, a 2, a 4, a 6, or an 8. If it ends with one of those numbers, then it's an even number. So 120 is even. That means that 2 goes into 120. Let's go through all these. Actually, let's start with 1, right? So we know that 1 is a factor of 120. Always start with 1. And I'm going to put whatever multiplies by 1 to give 120. I'm going to put that way down here at the end of the list, because that's going to be the last number, the biggest number, 120. Hopefully I left enough room. Let's see. So 1 times 120 is 120. Okay, so then the next one's 2, right? Because 120 is even. So 2 goes into 120. Now, what times 2 is 120? Well, hopefully you know it's 60. If you don't, you'd have to go off to the side and figure it out. Just take 120 divided by 2, 6 and 0. Alright, so then I'm going to put the 60 at the end of my list. So 1 times 120, 2 times 60. Okay, now let's check. Oops, that was supposed to be the eraser. Now let's check the next number, which is 3. Okay, does 3 go into 120? Well, the trick for 3 is to take the sum of the digits and see, is that divisible by 3? So we have the digits of our number in 120 are 1, 2, and 0. So I'm going to take the sum. I'm going to add those digits up. 1 plus 2 plus 0. So 1 plus 2 is 3, plus 0 is 3. Since 3 is divisible by 3, that tells me 120 is divisible by 3. And that will work every time for 3. It only works for 3, and actually 9 has a similar trick. The sum of the digits is divisible by 9. Okay, that doesn't work for other numbers. It's just for 3 and 9. So I know 3 goes into 120, so I'm going to add that to my list. Okay, so now 3 times what is 120? Well, 3 times 4 is 12, so it's going to be 40. Now notice my numbers are getting closer and closer together. So when you start this, you're thinking, oh my gosh, am I going to have to check 1, 2, 3, 4 all the way to 120? No, because the only numbers I'm going to have to check now are between 3 and 40. See, my list is getting much, much, much smaller, and these are going to keep getting closer. Any factors now are going to have to be between 3 and 40. All right, so let's go to the next one, 4. The last 2 digits are divisible by 4. All right, so to see if 4 goes into 120, all I really need to check are the last 2 digits, which are 20. All right, does 4 go into 20? Yes, it does. So therefore, 4 goes into 120. Great, so I'm going to add 4 to my list. Now 4 times what is 120? Well, 4 goes into 12 3 times, so it's going to be 30. Now my gap is getting even closer. I only have to check numbers between 4 and 30. Next one, 5. Does the number end with a 0 or a 5? Yes, it does. It ends with a 0. That means 5 goes into it. So I'm going to add that to my list. Now how many times does 5 go into 120? 5 goes into 12 twice. With 2 left over, bring down the 0. 5 goes into 24 times. So 24. So I'm going to put 24 over here. See if I left enough room. All right, next one is 6. So to see if the number is divisible by 6, we have to see if it's divisible by 2 and 3. So it has to meet these 2 criteria up here. It has to be both even, which it is. And actually, you could just check your list at this point. Is the number divisible by 2 and 3? We have 2 and 3 in our list, so yes, it's divisible by 2 and 3. That means it's divisible by 6. All right, so 6 goes on the list. How many times does 6 go into 120? Well, 6 goes into 12 twice, and then you have your 0, so 20. I may have to expand my list down here a little bit. I think I didn't leave enough room. This guy has a lot of factors. Okay, so we're just up to 6 and 20. Now 7. 7's kind of a weird little trick. Of course, you know, what you could always do is just divide it by 7. And sometimes that's faster. That's usually what I do with 7. But this is a trick that works. It's kind of interesting, if nothing else, and I'll go through it. But 7 goes into 12 one time with 5 left over, and 7 doesn't go into 50 without a remainder. So 7 is not a factor, so we're going to skip that one. But just to show you this little trick, it says to take the last digit and double it. So the last digit of 120 is 0. Okay, so let's write this out. I'm going to take the last digit and I'm going to times it by 2. I'm going to double it. Well, that's still 0. Okay, then I'm going to subtract that number from the remaining digits. So the remaining digits I didn't use here was 12. So I'm going to subtract 0 from 12, and I still get 12. And then I check and see if that number is divisible by 7. And 12 is not divisible by 7, so the original number is not divisible by 7. Let me show you that 7 trick with something that is divisible by 7. Let's try like 161, just so you can see it when it does work. So I take the last digit and I multiply it by 2. That gives me 2. Then I subtract the 2 from the other 2 digits I didn't use. So 16 take away 2, that's 14. And 7 is divisible by 14. So, I'm sorry, 14 is divisible by 7. I said that backwards. So therefore, the original number, 161, is divisible by 7. Now it doesn't tell you how many times 7 goes into it, but you know that it will go into that number without a remainder. So that's kind of a cool little trick. Alright, maybe we'll do an example where 7 goes into a number later. Well, we just did one, but I mean where we're finding the whole factors. Okay, so 7 doesn't work, so now we're down to 8. So to check and see if 8's divisible by a number, we want to see if half the number is divisible by 4. So we're going to take half this number, which is 60, and we're going to see is that divisible by 4. And And so the trick for divisible by 4 is to see if the last two digits are divisible by 4. When it's only a 2-digit number, you basically have to just check it. So 4 goes into 25 times. Yes. Yes, it is. So 8 goes into this number. So I'm going to have to figure out how many times does 8 go into 120. I picked a number with a lot of factors, didn't I? We should be getting close to the end here because 6 and 20 are pretty close. Let's see. So we got to figure out how many times 8 goes into 120. One time. 4 left over. Looks like 15. So we're down to 8 and 15. Okay, so if there's any other factors left, they have to be 9, 10, 11, 12, 13, 14. We're just down to checking those now. Alright, so the next number, 9, the sum of the digits is divisible by 9. Well, these digits only add up to 3, as we saw up here, and 3 is not divisible by 9. Okay, it's smaller than 9. So 9 is divisible by 3, but 3 is not divisible by 9. You can't divide 9 into 3 without it, and I mean, it's not big enough. So 9 doesn't work. 10, the number ends in a 0. Bingo, number ends in a 0, so 10 goes in there. Alright, how many times does 10 go in? Well, you just drop the 0 and it goes in 12. So the last number to check would be 11. I don't have any shortcuts for 11. There is kind of an interesting little shortcut if it's a 3-digit number, but it doesn't come up that often. So, alright, so we could just check it. It's not going to work here. That goes in once with 1 left over. 11 doesn't go into 10 without a remainder. So that's it. 11 doesn't go in. So boom, that's the end of our list. Okay, so our factors of 120 are 1, 2, 3, 4, 5, 6, 8, 10, 12, 15, 20, 24, 30, 40, 60, 120. Now I picked a number with a lot of factors just so we could go through all these divisibility tests, but most numbers aren't going to have quite that many factors, okay? But this was good to go through all these. Now, sometimes in some books they will ask you to find all the factors of the given integer, or they want integer factors. Let me write it that way. Integer factors. So when we say we want an integer factor, what that means is that we're just going to include the negatives. Integer factor. So for example, you know, we just said that 3 and 40 are factors. 3 times 40 is 120. Well, that's cool, but if we want to talk about all the integers, we could also say negative 3 times negative 40 is 120. So therefore, negative 3 would also be a factor, and negative 40 would also be a factor. If I want all the integer factors, then I'm going to have all these factors positive and negative. So the way we write that out mathematically as a shortcut, if I don't want just positive 1, I want positive and negative 1, I do this little symbol right here. And sometimes that's read plus or minus, but it really means positive or negative 1. So it's a shortcut for writing this. Instead of writing 1 and negative 1, I just put a plus or minus. That means I want both the positive and the negative 1. So you'd write positive negative 1, positive negative 2, 3, and this is how you see the answer written out. And of course we have tons of these factors, dot, 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 all the way to the end of all the factors. Okay, I don't want to take the time to write all those out, but you know what I mean. You just keep writing all these out till you get to 120 if you want the integer factors. All right, let's do one more example, maybe one with not quite so many factors, just so we can go through the steps here, but still a big number. Let's see, let's do something this like 56. That's got some factors, but not quite as many as the last one. Well, maybe we should do something a little bigger. Let's do 112. Okay. So if you want to pause the video and try this on your own, that's always a good idea, and then start the video again and see if you got all the factors. And I will wait 1 second and then go through it. Alright, so let's do the factors of 112. Of course, we're going to start with 1 and 112. So I'm going to organize this one a little differently this time in case I run out of room. I'm going to put it underneath here like that. 1 and 112. Okay, then I'm going to go to 2. Is the number even? Yes, the number's even. So divide that by 2 and I get 56. 3, the sum of the digits is divisible by 3. So if I take the sum of these digits, sorry about that. If I take, I always turn off the phone before I start the videos. If I take the sum of these digits, 1 plus 1 plus 2, if we add these digits up, we're going to get 4. And 3 is doesn't go into 4 nicely. Okay, so skip 3 and we go to 4. The last 2 digits are divisible by 4. So all we're going to do is we're just going to look at 12. Yep, 4 goes into 12, so 4 is going to go into 112. And then we need to check how many times. So that goes in 4 times 32, or 4 goes into 32 8 times, so we get 28. Alright, so now we have 4 and 28. We're getting closer, so the only factors now can be between 4 and 28. Alright, let's check 5. The number ends with a 0 or a 5. Nope, ends with a 2. 6, the number is divisible by 2 and 3. Well, we have 2 in our list, but we don't have 3. It wasn't divisible by 3, so 6 is out. 7, take the last digit and double it. Okay, so we're going to take this last digit and double it. So we're going to times that by 2, which is 4. And we're going to subtract that from these 2 digits, and we're going to get 7. Now, does 7 go into 7? Yes, it does. So therefore, 7 goes into 112. Interesting. All right, so let's divide that. That goes in once. Subtract that, we get 4. Bring down the 2. 7 goes into 42 6 times. 16 times. All right, so 7 times 16 is 112. This is getting close here. See, we only have to check numbers between 7 and 16 now. 8, half the number is divisible by 4. All right, so half this number is 56. Is that divisible by 4? Well, let's check it out. 56 divide 4. Looks good. Looks like it is, so yes. And you know, with 8, you could always just check and see if 8 goes into it. Sometimes these shortcuts, you know, sometimes they're shorter and sometimes they're not. We could always just see, well, does 8 go into 112? 8 goes into 32 4 times. Yes, it does. All right, so we're good. So 8 goes into 112 14 times. Excellent. 9. Well, I'm going to tell you right now, if 3 doesn't go into the number, 9's not going to go into the number, because any number that 9 goes into, since 3 goes into 9, it would have to go into that bigger number. So 9's not going to work. The sum of the digits is 4. That's not going to work. 10, the number ends with a 0. Nope, that doesn't work. Okay, so we know we don't have 9 and 10. And the only numbers we would have left to check then are 11. Let me write these in red. 11, 12, 13, 14, and 15 are the only numbers we would have to check. Now, a couple little shortcuts here. Again, if 3 doesn't go into this number. Alright, so if this number is not divisible by 3, it's not going to be divisible by any number that 3 is a factor of. So you can rule those guys out. Alright, cancel those out. So that leaves these. Now 14 might work. Let's check 14. Let's see. How about 14 times... let's see, 14 times 8 maybe? Let's see what that comes out to be. That's 32, carry the 3, 8, 9, 10, 11. Alright, so 14, oh, we had 14. That was dumb. We don't have to check 14. Why did I write that down? We only have to check numbers between, yeah, we didn't need to check that because we have 14 right here. Sorry about that. So we checked 9. We only had to check numbers 9, 10, 11, 12, and 13. And we checked 9 and 10, so that only leaves those. Sorry about that. Okay, so now we only need to check 11 and 13, and we could just multiply and see. We could try 11 times 10. 11 times 10 is 110, so it's not going to go into 112. 13 times, well, it's not going to work. But just to check it out, we could try 13 times 8. So that's 20. I'm just guessing and checking here. All right, so that's 24. Trying to get in the ballpark of 112. So that's 104. If I did 13 times 9, that's 27. Carry the 2. That's 117. That's too big, so that doesn't work. All right, so none of those. All right, so there's my factors. If I want to write them out as integer factors, I would say that the factors of 112 are plus or minus 1, plus or minus 2, positive or negative 4, 7, 8, and then I'd want to start going this way because I want to write them in order. 14, 16, 28, 56, and 112. So that one still had enough factors to make it interesting. Alright, so I hope that helps, and a lot of these problems, the numbers you're going to get are going to be smaller, like 20, and so these tricks will make it go really fast. You'll have 1, 20, 2, 10, 3 doesn't work, 4, and 5, and you're done. And so kind of coming in from this direction and matching these pairs up with these smaller numbers, and you get to 4 and 5, you're done because there's nothing in between there. Alright, so I hope that helps, and these divisibility tests should come in handy with other things that you're doing as well.